Let's go ahead and take a look at a full four-step example of a chi-square goodness of fit test. So we're going to use that data that we had about what we observe, which is here, the number of professors by ethnicity, and we want to see if those observations fit the expected distribution of the U.S. Census. So the computer will do that, but here's the setup, how we write the test. Okay, and then we have the four steps. Step one, what are the null and alternative hypotheses? The null hypothesis is that the proportions that we observe, let me fix that right here, right, that we observe, let me write an OBS there, the observed data right here, right, that somehow what we observe matches the expected, and that's why you'll see the proportion of white equals 0.601, the proportion of Hispanic and Latino equals point. So that's our null hypothesis, that's nothing is different, that's what is, and you'll see that's our statement. The alternative is that at least one of these is not correct, right? It doesn't match up, it doesn't fit. And so we use the same test, I mean the alternative every time that it doesn't match up. We'll run the test. You'll get a goodness of fit test. Step two, what is the test? Alpha level 0.05. I don't think we've said that. Yeah. So we'll state that there, right, if it's not stated. Step three is to get the chi-squared value, get a big number. The p-value is really small, which then leads us to the conclusion. Since the p-value is less than alpha, right, 0.000 is less than 0.05, we reject the null hypothesis. And so we'll say we have sufficient evidence to conclude the distribution of race among faculty does not match up to the distribution of the census data, right? And so let's go and take a look how to do that in ArtistStat. So when you get to the ArtistStat, we're going to go ahead and look for, we'll find it, scroll down, and there it is, chi-squared. Oh no, sorry, continue on. I have it further because that's just for distributions. There it is, chi-squared tests. We'll click on that. And once you get here, we look for tests for independence, right, which is later. We're going to do goodness of fit test. We have 5 categories that we're looking at. You could change that. We have 5 categories. And then we're going to go ahead and enter in the data here. So I need data for white, Hispanic. I'll fill in the rest. I'll pause here. So we'll see here I have the data in. I have the counts in. That's from the data from our notes. How often those categories came up. These are the proportions that are in our alternative hypothesis. Make sure they're all correct. And then you just hit submit. That's it. And then when you hit submit, you get all the things here. So there's some homework problems where you're asked for what's the expected values, given the distribution, right? Given what the hypothesized proportions are from the null hypothesis. And then, so you get the expected counts for those categories. And then what we care about, there's the null hypothesis we stated. There's the chi-square test statistic here. There's your p-value. Degrees of freedom is related to your number of categories, which is always categories minus 1. But we can see then where we got this data from. And so it does the calculations for us. Step 5 on this course would be, was the data collected random? We don't know. Was the sample size large enough, right? So we ask those questions as we go through that. We see back here that we need a large enough sample size to apply. One rule of thumb is that the expected counts for all the categories are at least 5. So we need to have enough data, right? Enough things to compare. So it is large enough there. And then, of course, what are the questions you may have? So that's a chi-square goodness of fit test. We won't do the hand calculations. I'll leave that up. You'll use ArtistStat to run it. You'll be given proportions, and you will be given counts. Or if you're given proportions, you have to take the percentage of those to find the observed and then compare it to the expected.